Welcome to Espresso Electronics, quick sips of EDA wisdom. Today we're going to explore an interesting and rapidly changing field, which is how is machine learning being applied and used in simulation-based environments. I'm your host Anika Sunda, and joining us to explore this interesting field is Yoshi Watanabe, who is a senior software architect at Cadence and a leading expert in artificial intelligence and computational simulation. Welcome to the show, Yoshi.
Thank you very much for having us, Anika.
So Yoshi, you deal with numbers, data, algorithms day in and day out. So to just kick off things, can you give us an overview of how machine learning is really being currently utilized in simulation-based environments?
Yes, thank you. My team is responsible for research and development of a product called SimAI. And the SimAI combines machine learning AI algorithms together with combinatorial optimization algorithms to synthesize simulation tests for verifying RTL designs. So RTL designs are verified using simulation tests simulated by Cadence logic simulator Xcelium. And our tool, SimAI, collects and monitors data coming out of Xcelium and then generates new test scenarios to achieve the verification goals more efficiently. Verification goals, I mean, for example, finding new bugs or stressing particular specific failure scenarios that were recently found and humans thought are interesting to investigate, or create more test scenarios for exceeding the design coverage conditions that the human designed, either for functional coverage or code coverage.
Yoshi, I'm sure that all the work that you do, I mean, not necessarily everything results into a positive impact, right? I mean, some can be permutation combination, some things might fail, right? So can you share examples of the same AI technology, the areas where you've seen that it has made a significant impact?
Sure, yeah, that's a good question. Let me give, two examples. One is about efficiency that SimAI achieved, and the other is about the quality of verification. On the efficiency, customers often use SimAI to produce a much smaller regression set. Regression set is a set of the test scenarios simulated for verifying RTL. And that is much smaller, but achieve or actually exceeds the verification goals. Quite recently, one of our customers reported that by using SimAI, they could get a significantly smaller regression set, which actually runs 20 times faster than their human-crafted the regression set. But moreover, that they actually exceeded the design coverage much more than what human-crafted regression set could achieve. Another case for quality of verification, we were told by yet another customer recently that they applied SimAI at the stage of the verification, which is fairly late, where the design was already very stable. But SimAI exposed new test scenarios stressing particular areas of the design, and then found a new failure signature that this human design and verification engineers had never seen. So they debugged these failures and then confirmed that it was indeed a bug that they were not aware of. And they're very surprised that in such a late stage and stable design, still be able to identify such a bug by using our technology. And also they're very happy about that.
Wow, this sounds very exciting. So with such great potential, the examples that you've given us, Yoshi, I mean, what challenges do we face in pushing the boundaries of what's possible with machine learning and simulation today?
Okay, in terms of challenges, I can think of two different kinds. One is a challenge from the tool technology point of view. In AI world, what are the challenges? The second is challenges from a human's perspective. What does this mean to human? In terms of tool technology, we are developing this tool technology, right? And so that we observe that the requirements for AI, in our case, are very different from those typical AI applications that the people are talking about these days. For example, our customers' data, which our tool needs to learn about, are proprietary. And so that it's not like we can take this one customer's proprietary data, learn about it, take another customer's data, combine them together, learn more, and then apply the result to yet another customer. We cannot do that. And so what we do is that we ship our algorithms of building AI models to the field, to the customer's place, and then at the customer's place, these algorithms are going to build proprietary AI models using only the customer's proprietary data. And then those models or data are not going to be shared at all with other customers or not even with us. We do not know what kind of models are being built. We just give algorithms. And this requires very quick learning in AI technology. And in a very short period of time, it needs to be able to produce useful test scenarios. And this is very different, spending lots of time in the central location, building good AI models, and then finally start applying it. It's not like that. Another very big challenge for us is that the rules of games keep changing. The AI rules are very important. It's all about how to take advantage of underlying rules of the data it is learning. Rules could be grammar of languages for typical cases, or could be rules of games like chess. And those rules do not really change that rapidly. But for our case, in the domain of the design verification, those rules are actually the logic of the design or functionality of the test bench or test behaviors. By nature, these are the things that keep changing. You find the bugs and you fix it, or you add new tests and so on and so forth. So every day, those rules changing. So from the AI's point of view, things they learned today as a rule may not be true tomorrow. And so it required to adapt those dynamically changing rules very rapidly and then be able to adjust ourselves in the models to be able to produce meaningful test scenarios. So those are very interesting and also challenging problems from the tool technology point of view. Now, for human, most challenging thing is understand what AI is doing. Human needs to be in the driver's seat to manage all this verification work. But SimAI finding something interesting, finding new bugs or new test scenarios that are actually going to find a new design coverage that the human cannot do easily. In those cases, human verification engineers always ask, how did this tool do that? But AI is not necessarily good at explaining their findings in a manner that the human can understand. And so that it's really important and challenging problem that how AI should be able to communicate to human about their findings in such a way that the human can understand.
Absolutely, Yoshi. I totally agree with you. It's very clear that we are standing at the precipice of a new era in simulation technology, right? I mean, machine
Right.
learning, as you mentioned, is not only to enhance the accuracy and efficiency of simulation, it's also revolutionizing the way we approach the problem solving and the
Exactly.
decision making, right?
Right.
Yeah. And the other question that I have, Yoshi, is that in context of regression verification, what implications do you see that the future AI solutions have for humans? Do you think there'll be a tug of war or competition between the human experts and AI, or will AI take over the roles of human engineers? I mean, or do you really think there can be a collaborative approach?
Yeah, that's very good question. Yeah, many people ask that what AI means to human, that we're scared of this. And by developing the SimAI technology, I'm fully convinced that the AI can take the quality of the verification in the totally different new level, way beyond what the human could achieve. But I'm saying this not because AI is superior to human or AI is going to replace a human verification engineers. I'm saying this because AI is attacking this problem in a totally different ways that from what the human would do. A human is always good at abstracting complex things. And then this abstracting world, it makes plans and then execute plans. This is not just about the verification. I think this is the wisdom that the human established. This is really the bread and butter the human do: abstraction, planning, execution. And AI doing that way. AI simply dives into data, and their abstraction is very different from what human would do. The result of the abstraction is not something that the human needs to understand. It starts to find some individual cases, starts to correlate those cases, and then that starts to find some patterns that these are very popular cases, these are not popular cases, this is actually very, very rare cases, and then tries to steer the focuses on specific ones. Either this is most common cases or most rare cases, or so on and so forth. That's what AI does. So in the context of the design verification, for example, in SimAI cases, it monitors all the simulation traces coming out of Xcelium simulator, and then starts to find individual cases. What kind of the values are assigned to here and there, and then starts to correlate those to design conditions. Whenever these kind of things happen in the test bench, these things seems to be stressed in the design side. What's the relationship between them? What is the most common scenarios that are stressed? What is very rare scenarios? What is the vulnerability in the design? Then start to observe those things from the ground, and then start to shed light that let's focus on this, and so on and so forth. They trying to solve the same problem, but very different manner. And by doing this in a different way, you often find new ways, the new things that are not so easy for the other side to be able to find. So the AI can find the things that the human cannot find really quickly, and vice versa. So I do see this is really complementary things. And I actually think this complementary approach, trying to attack the same problem in a different perspectives, and then by collaborating it, taking the quality of the verification to new level, is a natural evolution that what we observed in the verification field. If you look at like very old times, 60s and 70s, and probably through sometime in the 80s, that the verifications were mainly done by the people who actually designed the logic. Those are the designers' verification. Those people design logic and then verify. But this hit some plateau, and then in 80s, 90s, really, that we introduced a separate group of people who only do verification. And those are the people who do not know about hidden assumptions of the designs, and they provided the different perspectives for the design verification problem. Because they are not involved in the design, they can verify things from the different angles, and then collaborating together with the designers, they brought the quality of the verification in a totally different level. And I now see the same analogous things with AI. this separate group of people, verification engineer we call, is great, but still it's human perspective to try to verify this. Now AI coming in as yet another agent, and this is not human. And so it doesn't do the same way of abstractions and so on and so forth like normal human would do. It just dives into the design data, and then it provides yet another perspective. So now we have the designers, verification engineers, and AI agents. All these three looking at the same problem from the different perspectives. And so by having this collaboration and then really tried to create this structure systematically, I think that we can do much better the quality of the verification. And that's how I see. So it's not really competitive or fighting or anything. It's really the collaboration of having the new agents into the verification problem.
Wow. Thank you, Yoshi. It's been a pleasure having you on the show. And thank you for sharing your thoughts, right?
Thank you. Well, thank you, Anika. I'm very convinced, as you can tell, that the AI can play a unique role in the domain of the design verification. And, it's complementary in nature. It's really the beauty of what this technology can bring to the world. And I'm really looking forward to unlocking the new horizons of the design verification doing this. Thank you.
Absolutely. Thank you, Yoshi. Thank you, listeners. So keep your circuits connected and your ideas flowing until we meet again on Espresso and Electronics. Stay innovative.